problems the whole period if you would like me to. So, what is your first question? Anybody have a question below 59 they'd like me to answer? Yes, Clara.
42.
Can anybody go lower than 42? All right, we'll start out with 42. So I'm going to keep it on the same paper here, so keep this all together. 42, let's do some chemistry. 42, we have performed the following mathematical operations expressed to sig digs. So what is the question about 42? Who asked for 42?
Oh, I did. I think I just got like a little bit.
What do you mean?
All the numbers.
Okay, so 42A, I'm just going to throw this up here because I don't think I'm going to want to have to write all these things down. Okay, so 42, when I'm doing this, can you guys see both things? Wow, look at that. So 42A, I have 6.022. I like to use EE in my calculator when I'm using exponents 23 times 1.05 second EE2. My calculator spits out 6.321 times 10 to the 25th. I've got 4 sig digs, I've got 3 sig digs, so my answer should be 6.32 times 10 to the 25th. What did the book have? 42. Let me check that. Yep, 6.32 times 10 to the 25th.
And then after that, do you put sig digs?
So your sig digs would be 6.32 times 10 to the 25th.
Yeah, so 3 sig digs.
3. Yep. B, I would do the following. 6.626 second EE negative 34 times 2.998 second EE8. It's funny because that's Planck's constant and that's the speed of light, which you guys would probably not know that. Equals divided by 2.54 second EE negative 9. So I'm looking for 3 sig digs. That gives me 7.82 times 10 to the negative what? 17th. That is what the book had. 7.82 times 10 to the negative 17th. You want to keep going, Clara, or are you good on this?
I'm good. Thank you.
Okay, cool. Okay, let's do 42C. 42C, I've got 1.285 times 10 to the negative second, so second EE negative 2 plus 1.24 second EE negative 3 plus 1.879 second EE negative 1. So I have on this, I have 1, 2, 3. I've got 1, 2, and I've got 1, 2, 3. And my answer should only have 2 after the decimal. So my answer should be just 0.2, just 0.20. So 42C. Yeah, it would just be 0.20. That's what the book had. 2 sig digs, only 2 after the decimal. Okay?
Thank you.
Awesome. Next one. Higher than 42. Yes.
Would you perhaps have one lower than 42?
Lower than 42.
24.
24. 24. We have, to determine the volume of a cube, a student measured one of the dimensions of the cube several times. The true dimension of the cube is 10.62 centimeters. Give an example of 4 sets of measurements that would illustrate the following data. So 24, I've got imprecise and inaccurate data. So 24, who wants to help us with this? So on this one, the true dimension of the cube is 10.62 centimeters. So if I'm looking at A, so 10.62 is the actual. 10.62 is, let's call that good. Let's call that good. If I'm looking for imprecise and inaccurate data, so I don't know, If it was imprecise, then my answer would be, I don't know, 11, right? That's imprecise because I don't have the right amount after the decimal. Inaccurate would also be, that's both, right?
Could you just put like, what if you just put 11?
Sure, but you'd want to have units.
Okay.
You'd want to have units. So that would be imprecise and inaccurate. B, so that would be A. B, I'm looking for precise but inaccurate. So I would have 8.62 centimeters. That's the right precision. I have 2 up to the decimal, but I'm 2 centimeters away from the answer. Yes?
So precision is the numbers after the decimal.
Precision is sig digs, essentially.
Okay.
That's your numbers after the decimal. And then C, precise and accurate. I gave you that. That's basically your C. Okay?
And we have to do 4 examples for each letter?
Yeah, but I'm just going to do one. Yes?
Will questions like that be on the test?
No.
Or will it be more dimensional analysis?
Dimensional analysis. This is more just conceptual, like making sure you get the difference between those. Okay, next one. Anything lower than 24? Okay, so then we're going above 42. Next question.
83.
Can anyone go below 83 but above 42? Yes.
53?
53. Okay, 53. Anyone want anything below 53? Okay, let's start 53. All right, 53. Here we go. So 53, is this the light speed one or warp speed?
Yeah, warp.
I love this one. What show is this from? Star Trek, yes, okay. Science fiction often uses nautical analogies to describe space travel. If the starship USS Enterprise captain was for a piece of candy.
Captain
No. So close. Jean-Luc Picard. Oh, wait. Pause. Hold on. It might have been Captain Kirk. I think Jean-Luc Picard is his real name.
I think it's Captain Kirk.
I think it's Captain Kirk. Who said that?
That was.
Was that you, Liam? I owe you a piece of candy. Go get a piece of candy. Third drawer down over there. Jean-Luc Picard was his actual name. Who was also the guy in X-Men. Not Magneto, the good one.
Cyclops.
Professor X. Yeah, same guy. Did you get something?
I did, thank you.
Great. Okay. All right. So 53. Wow, I got way off track there. We use nautical analogies to describe space travel. If the USS Enterprise is traveling at warp factor 1.71, what's its speed in knots, in miles per hour? And that's it. So they say that warp is 5 times the speed of light. The speed of light is 3 times 10 to the 8 meters per second, and 1 knot is 2,030 yards per hour. So on 53, I started with warp. Okay? So I said that 1.71 equals the following. They said that is equal to 5 times the speed of light, right? And they said the speed of light is 3.00 times 10 to the 8th. But what I did is I put it meters over 1 second. So I split that into its dimensions so then I can actually convert with that. If I ever get off the screen, you guys got to let me know. You got to let me know because it'll happen. Then I know for this, I'm trying to get to what? I'm trying to get it into knots in miles per hour. So in order to get it into knots, I know I have to get it into yards per hour, correct? So I need to get meters into yards. In order to get meters into yards, what am I going to have to get it into first? I know I'm going to have to get meters to what?
miles.
No. What is my gateway conversion? Centimeters, right? Because my gateway conversion is 2.54 centimeters in 1 inch. So the first thing I'm trying to do is get this 2 centimeters. So I'm going to say 1 meter is 100 centimeters. And there is 2.54 centimeters in 1 inch. From there, I know that there are 36 inches in 1 yard. So I have my desired unit on top. But we know that a knot is a yard per hour, right? Right now I have yards per seconds. Why did I say it like yards? Did you guys hear that? Was that weird how I said that? I felt like it was weird. No? Okay, I'm just making sure I'm not awkward. I know that there is 3,600, don't answer that. If I am, it's fine. There's 3,600 seconds in 1 hour. If you want to make that 2 steps, I don't care. If you want to say that there's 60 seconds in a minute, 60 minutes in an hour, that's fine. This just saves a step. So I now have yards per hour, right? We good with that? So, can I solve? Am I good to solve? I have to still say that I get one more step left because there is 2,030 yards per hour in 1 knot. If I think about this, when I'm dividing, I'm going to actually be dividing by the reciprocal, right? So this yard on the top actually would be a yard where? On the bottom, which would cancel out that yard, right? This hour, when I divide it by, is actually an hour on the top, which is going to cancel out that hour. So that gives me my answers in knots. Which knots are just like tied pieces of rope. Like it's really kind of weird when you think about it. I think. Is that right? Anybody here sail? Mariska, am I right? I don't know. Liam, am I right? You're a Star Trek person. Okay. Okay. Anyone here have a sailboat? You have one? Oh, okay. Anyone here sailed on a sailboat before? Okay. I have also sailed on a sailboat. It's fun. It's not mine though. 53. I know that I need to have 3 sig digs because I started with 3 sig digs. So I got 2.91 times 10 to the 9th knots. So that is my 53. On 53B, it then asks for it in miles per hour. So the thing that's going to be different on this is going to be what I convert it to. So I'm going to go again with my 5 times, for every 1 second, there is 3.00 times 10 to the 8th meters. There is 3,600, I'm going to do my seconds first, doesn't matter when, seconds in an hour. For every 1 meter, there is 100 centimeters. There's 2.54 centimeters in 1 inch. There's 12 inches in a foot. And there is 5,280 feet in 1 mile. So that will give you your miles per hour. So you should get with that 3.36 times 10 to the 9th miles per hour. 3.36 times 10 to the 9th miles per hour. So that was 53. Helpful?
Yeah.
Okay. Next one. After 53. I've done 59. I have done 60. I've also done 97 already. What else? Don't be shy. Dan, you got one or no?
Well, I thought someone had one in the 80s.
I thought so too.
82.
82. Can I flip the page? Okay. Oh, 82 is a good one. Also kind of fun. Because 82, we've got a sphere, right? Oh, kind of. No, we have a cylinder. A cylinder. When you're thinking cylinder, what are you thinking? Pringles. I love that. What else are we thinking? I'm thinking pi r squared h, which is the volume of a cylinder. But I like Pringles first. I love that. It's incredible. That's the best answer. Yeah, because what else would you think of for a cylinder besides Pringles? You could think of Lay's Stacks, but no one thinks of Lay's Stacks. Right? Anybody here think Lay's Stacks is better than Pringles? Raise your hand. Be proud of it. Is that a hand, Daniel? You think they're better? Okay. You are entitled to your opinion. That's fine. What else do you think of for a cylinder? So we got Pringles, we got Lay's stacks, Oreos that come in the sleeve, like that. Could you know what I'm talking about? Ritz crackers, that's a cylinder. A pickleball thing.
Like the ball.
Oh, the ball tube for like tennis balls or pickleballs. Toilet paper roll. A silo. Guys, this would be a great, what's the show with the guy, Steve Harvey? Family Feud. Like, name the top 5 answers to this. Things you think of when you hear the word cylinder. Probably pi r squared h would not be on the top 5. Pringles would probably be the number 1 answer. So it's time to go on Family Feud. I will be part of your family. We'll call it Heller's AP chemistry class.
Let's do it.
Do you want to be the captain or should I be the captain?
You can.
Are you sure? Okay. Do you want to be the second one though? I feel like you've got a better answer. You have a better like idea of like, you know, of like the pulse of America. So I'll go second. You can be the captain.
Top 5 answers.
Okay. All right. Who else is coming with us? We need 5 people.
I'll get with you.
I'll go.
Yeah. Okay. We got 4. Okay. We got 4. All right. Glenn. Okay. Blaine. Sorry, Arch. You raised your hand too late. You're first alternate. So. Okay. Steve Harvey seems like a cool guy. Like, I'm just saying. He does. All right, 82. A copper wire. Density 8.96 grams per centimeters cubed. There is your rate. Remember, I said on the notes to save the rate. It's like save the date, but save the rate.
Save the date.
Yeah, save the rate. Has a diameter of 0.25 millimeters. If the sample of copper wire has a mass of 22 grams, how long is the wire? So on 82, I am solving for the what? The height or the length, correct? And the V equals pi r squared h, I'm solving for the h.
Yes.
Okay. So I'm just going to write down, I know that I'm going to have to do something with V equals pi r squared h. So I am just, you know, brainstorming here what I'm going to do with this. I know I'm going to do something with that. Are you okay, Dave?
Yeah, I just hit my phone.
I saw that. All right. So on 82, they give me a diameter of 0.25 millimeters. They also tell me that I've got a mass of 22 grams. Here's what I would do first. I would take my 22 grams, and they gave me a density, right? Yes? They said that there's 8.96 grams per centimeters per 1 centimeter cubed. So the first thing I would do is I would convert that to centimeters cubed. What do you get for that? You get 22 divided by 8.96. You get 2.5. Does that sound right? That gives me 2.5 centimeters cubed, which is my what? My V, right? Do I have pi? Do I have r? Kind of. I have a calculation I have to do, but yes. And could I solve for h? Yes, I could. So I'm going to set this up as an equation. I'm going to say that there's 2.5 centimeters cubed is equal to pi times r squared. For my r squared, I'm going to have to do a calculation, right? I'm going to have to take my 25 millimeters and divide it by what? By 2, right? And then I also have to convert that into what to make my units work? Centimeters, right? So I'm going to say that there is 10 millimeters for every 1 centimeter what? Cubed or squared? This would be centimeters squared, right? There's ones. You wouldn't say cubed there, you'd say squared. So I have to multiply those together. You guys with me so far? Times h. Solve for h. Millimeters are gone. If I take centimeters cubed divided by centimeters squared, what am I going to end up with? Centimeters. I'm going to end up with centimeters. So I got H, which is equal to L, which is what they're asking me for, is I got 5.1 times 10 to the third centimeters, AKA long. It's like 5,000 centimeters. It's like 50 meters. That's a long steel cylinder. Or copper. Copper. It's a long steel copper wire. That was 82. Next one. Is there another one?
How about 91?
91. Did I do that one yet? I did not. I did 97. 91. 91. I have following. Classify the following as physical or chemical changes. 91. I'm just going to throw this up here so we don't have to write this out. Number A. Mothballs gradually vaporize in a closet. This is actually a great question. Raise your hand if you said physical. High if you said physical. Raise it high. Who said chemical? You did not get to this question yet. Okay. 91, it's vaporizing, right? Which means it's just evaporating, yes? Which means it's just a physical change. It's still the same thing, just spread out. Still the same thing, just spread out. B, hydrofluoric acid attacks glass and is used to etch calibration marks on glass laboratory utensils. What'd you guys say here? Physical or chemical? Chemical, right? In order to etch it, right, you're changing the composition of the glass to have that etch back. So that's chemical. A French chef, have you guys watched The Bear?
No, but I've heard it.
You've watched The Bear?
Aren't they in Chicago?
I know, but I know it's in Chicago. I'm just like thinking of like the chef. Makes me think of Chef Carm. They did some training in France on that show. Who has watched The Bear? Did you like it? I thought did you watch season 4, the last season?
I'm still working on it.
Okay, when you finish the last season, let me know what you think. Okay. All right. French chef making a sauce with brandy. You got to say it more like, how would you say it with a French accent? Brandy? Yeah? I'll ask Madame. Is able to boil off the alcohol from the brandy, leaving just the brandy. Physical or chemical change? Physical, boiling. It's just going from a liquid to a gas. D, chem majors sometimes get holes in the cotton jeans they wear to lab because of acid spills. Chemical or physical? Chemical. That was 91. Any other questions? 97. I think I did 97 already last period. So I already did 97, so watch that from last period. Anything else?
About 98.
Sure. 98. 98. We got time. So, 98. In the opening scenes of the movies Raiders of the Lost Ark, has everybody ever seen Indiana Jones at Hollywood Studios? The show where they like acted out. Only Micah?
I'm proud, man. I'm proud of you.
That is a great show. Who has seen the movie at least? Okay, good. Is Raiders of the Lost Ark, is the end scary?
Which one? What's the end of that? Which
Like where they find the Ark of the Covenant and then they like open it and they like kills all the Nazis?
Yeah.
Is it kind of scary?
It used to be scary.
It melts their faces.
When I was like 7 and I was watching it, it was terrible.
Like, what is the appropriate age for me to show that to my daughters?
Like 7 or 8, but like tell them to close their eyes.
I'm worried to show it to my wife, okay? I think she would be scared.
Just tell them to close their eyes for that part.
Okay, but like, it's like kind of the whole point of the movie is like, you know, don't open Pandora's box. Like, yeah.
Wait, is that the first one or like?
Raiders of the Lost Ark is the first one.
Yeah.
Yeah. The last one is like,
He's like old with like
I haven't seen the last one.
with like little kids.
I don't know if I want to see it. Because like the Crystal Skull almost like was bad enough.
He's like an old guy and all of his partners.
Like Indiana Jones we need a new Indy. Chris Pratt.
No,
No?
Nobody can replace Harrison.
Who should it be?
Harrison Ford's not the only one.
The franchise has to continue.
No, it doesn't. Just like Star Wars.
Just
can
end
do
it?
all those new movies.
I heard Star Wars is going to try to create like an Avengers Endgame type 2-movie finale for like this Star Wars saga. So like Rey will still be in it, and then they're going to pull in all the old characters if Harrison Ford is still alive, like, which
Yeah, literally, bro.
he's getting up there.
6 days, 7 days.
He's getting up there.
You ever seen that movie?
What movie?
Harrison Ford, 6 days, 7 nights.
No.
You should.
Is it? Okay.
It's a good movie.
I'll check it out.
My mom showed it to me.
98. In the opening scenes of Raiders of the Lost Ark, Indy tries to remove a gold idol from a booby-trapped pedestal. He replaces the idol with a bag of sand. Approximately equal volume. Then it tells me the density of gold, the density of sand. Did he have a reasonable chance of not activating the mass-sensitive booby trap? First question is, how do we know it's mass-sensitive? I don't know. How do they know? I don't know, but let's answer it. So 98. On 98, I know, here's how I would start this one. I'm going to start out with just, I don't know, B. Assume the volume of the idol is 1 liter. So I've got 1.0 liters. So I'm going to change my liters to what? What was the rate they gave me?
Grams per centimeter cubed.
Right, so I need to get my liters to what? Centimeters cubed. So I know that 1 liter, I know that for every 1.0 liter, there is 1,000 milliliters. I know that for every 1 milliliter, there is 1 centimeter cubed. Right? I could have just went liters to 1,000 centimeters cubed. If you wanted to, I'd be fine with that.
Wait, what is that?
This, 1 centimeter cubed. 1 liter is 1,000 milliliters. And then I'm going to use my rate. They gave me the density is for every 1 centimeter cubed, I have 19.32 grams. That is dense. 19.32 grams. Let's convert that to kilograms just so we have a better idea, because we know that they're like 2 kilograms in a pound. So for every 1,000 grams, I have 1 kilogram. If you solve that, that is 19.32 kilograms. That is approximately 48 pounds. So if you've seen the movie, how does he do it?
Rolls.
He goes like, there ain't no way. There's no way. Yes. Sure. Yeah. Let me zoom in just a little bit.
What if he has another perfectly weighted piece of, like, he drops the, what if he like replaces it with another thing?
Bag of sand.
Bag of sand. That's a lot of sand in there.
That's what I'm saying. For the bag to get 40 pounds of sand, that's like a bag of sand this big. So what we're saying is you're answering part A. So part A, the answer is no. The answer is no, that is not possible. So, is playing catch with the idol when they throw it back and forth? No, not possible. Yes, unless no. Even if you're really strong, there's no way. It wouldn't look that easy. You'd be like, I mean, yeah, but no. I mean, he wasn't that ripped in any movie.
Well, he also had a long sleeve shirt on.
That is a good point. I have not. Yeah, you're right. He doesn't wear cutoffs very often, so I guess sun's out, guns are not out when it comes to Harrison Ford.
The deserts, you gotta keep the sleeves covered.
That's true.
And you
That's
get
true.
sunburned.
Yeah. Harrison Ford probably has a farmer's tan.
Especially if he's using a whip all the time.
Yes. Yeah. All right, so that was the questions. So I will post this period and